We already have a cure for coronavirus and they are keeping it from us. Hi guys, welcome to my channel, Nadine Speaks. Now if you're a returning subscriber, welcome back. If you have not yet hit that subscribe button, do it right now if you want to see this beautiful face on your feed, because I'm about to drop some major science knowledge on y'all, because I am tired, sick and tired of hearing all the things that are going through the grapevine of social media that we already have a cure for coronavirus and they are keeping it from us. Yes, the government wants to kill us all. We are doomed. The only reason the virus is spreading is because they want to control the population. We're overpopulated and that's the only way we can kill so many people. They already have a cure and they're not giving it to us. The government's hoarding the cure because they don't want to see people alive. They want to kill people. I have seen this everywhere. I've seen this in the media and I have seen this all over social media, over people's statuses, all you conspiracy theorists out there. I'm sorry, but this is not a conspiracy. I'm gonna let you know in this video why there is no possible way that they could already have a cure for coronavirus, especially a coronavirus that just came about at the end of last year, because I want to debunk for you guys how long it takes to even come up with an antiviral medication and how the hell they do come up with antiviral medications, because I'm sure you're wondering about that. Because I'm a scientist, but I had to once again take everything into my own hands and research it for myself. And honestly, you can do this if you have a computer, if you have a cell phone. You can use Mr. Google, thank you, Dr. Wikipedia, but it's really, the information is out there. You just need to find it for yourself. And if you're clicking on this video, thank you so much, because you are doing some research. This video could help you maybe understand in your mind how an antiviral medication works, how they come up with antiviral medications, what are the steps, what are barriers that scientists come across with releasing new medications, and preventative medicine, so vaccines, right? People, there's like this whole conspiracy on its own about vaccines and people usually don't even get them. There's so many anti-vaxxers out there, like hashtag anti-vaxxers, am I right? Leave me a comment down below if you're an anti-vaxxer or you know someone that's an anti-vaxxer, because honestly sometimes I just spend my time on Facebook debunking anti-vaxxers. It's really fun to get in arguments and debates with them and actually drop science, and that's what I'm here to do today, is drop some science on you. So what is the first thing I'm going to talk about? What is an antiviral medication? Now a lot of people are confusing with antibiotics, that an antibiotic can somewhat fight a virus, and that is false. Fake news once again. The only thing that can combat a virus is an antiviral medication. And these are medications that are made or even found in nature to stop or inhibit the replication of a virus. Now, when we're thinking about how we're going to stop the replication of a virus, there's the whole life cycle that we have to consider of a virus. So the whole life cycle, just like we have a life cycle, just like a cat has a life cycle, just as a bacteria has a life cycle. If you inhibit any stage of the life cycle, you can inhibit from reproducing. And like I said in my previous video, if you haven't watched it, I'll link it down below, on COVID-19. But if you cease to replicate, you cease to exist. And that is the basis for life. That is the basis for evolution. And what we're going to see with viruses is they can mutate really heavily. They can adapt to their environment. And this can be a problem that scientists face when coming up with these antiviral medications. So now that we got into what an antiviral medication is, what are the life stages of a virus? But generally how virus attack hosts, and remember I said before, leave a comment down below if you know what a host is right now. I'll give you a second. But it could be either a bacteria, an animal, or us, humans, hostess with the mostest. It just needs somebody or something, cell, to use that machinery to replicate, because it does not have that machinery on its own. All right, so when we're talking about a virus's life cycle, there are 5 main parts. The first part is attachment to the host cell. The second part is when it releases its viral components into the host cells. So like I said before, a virus is just a protein sac with genetic material inside. This genetic material can either be single-stranded RNA or double-stranded DNA. And I want you to think of DNA or RNA as codes or sequences that basically have the code to make a virus. Now, if you want to get in deeper, these codes are 4 different nucleotides, A, G, C, T. Now, RNA is a little bit different. It has just A, G, C, U because it's single-stranded. After a virus, one attaches to the host cell and releases its viral components into the host cell. Now it has to replicate. So this involves taking all the DNA or RNA that the virus injected and using all the machinery in the host cell to replicate its genome. Now, machinery includes different enzymes, and one of my favorite jokes actually has to do with DNA replication, and that's, boy, are you a DNA helicase because you unzip my genes. And it's really funny because genes, pun, hey, but basically there's a lot of different enzymes and most of them end with ACE. We have helicase, transcriptase, replicase, and kind of what they do is hidden within their name. If you want me to get into the basics of DNA replication, I would love to. There's actually a really cool 3D cell video models out there that actually show how a DNA replicates from the inside, and it shows every little enzyme. They actually are like little workers. So each enzyme works really hard to unzip the gene of its DNA, replicate what's going on with replicase or transcriptase, and then putting it into its little package and ready to form an actual virus. So that's basically the next stage of the virus life cycle, is that after it assembles the DNA with the host cell's machinery, it will come together and it will form a virus. So in that stage, it is now a complete virus living in the host cell. And then the final stage of the life cycle of the virus is releasing that completed virus back into the environment to attach to new host cells to infect them again. So this life cycle continues until most or all of your cells or the host cells are infected with the virus. And this kind of sounds scary. So I like to think of viruses as mini alien invaders. So if you think about it, they're basically invading your cells, replicating themselves, making babies inside your cells, and then releasing the babies to infect more host cells. So I don't know if y'all have ever watched Doctor Who, but I love Doctor Who, and I kind of think of viruses as Daleks. So they're like terminate, and they're trying to terminate your host cells and basically live as parasites in your body until they keep replicating. And also, a big thing about DNA replication is that within the replication cycle, mutations can happen. And this is so scary to think about because we only know that there's one strain that's causing the outbreak right now, COVID-19, and that's a specific genome sequence. Well, if you think about it, the DNA is being replicated or the RNA is being replicated. If one of the code changes in any way, and the codes can change by insertions, deletions, or it actually moves, which is even crazier, and it's hard to explain simply, and it's hard to explain without showing you something visually as well. I know I'm a visual learner, and that's really how I try to really understand science, is zooming in on the inside of the cell and seeing what actually happens. But basically, you can have an instance where the gene now mutates, so it changes in any way, shape, or form, and now you have a new strain of a virus. And that's what's kind of scary to me to think about, and I don't want to scare you, but I'm just saying it's possible that there could be multiple strains of the same kind of virus floating around. Now, they haven't found this yet, so don't freak out, but that's how there's new strains of the flu virus every year, is because it will mutate in your host cell. A mutation will happen, and now we have a new virus. So that's actually one of the complications when trying to make an antiviral medication, is keeping up with all the changes in their mutations. So now that I talked about the stages of the virus's life cycle, we can now see how scientists are looking to make an antiviral drug to attack one of these stages of the life cycle. So they can do this by genomic sequencing, figuring out the code of the virus and attacking those specific codes in different stages of the life cycle. So the first way we go about attacking a virus is the first stage. So inhibiting it basically from latching onto your host cell. So there's two ways that you can inhibit this first stage of the life cycle. The first one is to actually inhibit the virus associated protein. So this is the protein on the virus that actually allows it to attach to your cell. The second way to do this is the other way around. So it is binding to the cell receptor on your cell to make sure that the virus cannot attach to your host cell. These two ways block the virus from attaching to your host cell at all. So it deals with blocking the entering of the virus. However, after it enters, there's many ways that we can inhibit it after that. So firstly, we can block the uncoding process. So this is blocking any of the enzymes that degrade that protein coat to allow the genes to enter the host cell. And then the third way is to block any of those enzymes that allow it to replicate. So blocking the transcriptase, blocking the replicase, blocking the helicase. So any of those enzymes that are used, and that's all your cell's machinery, can be used to stop that replication cycle from the virus's genes replicating into your body. And the last way, which is actually the most popular way, is blocking the release of those viruses to infect new host cells. Now, this is what we see when we talk about Tamiflu. So leave a comment, leave a like below if you know what Tamiflu is, but that is the most common antiviral medication to treat the flu. And so we see that the Tamiflu specifically blocks the enzymes that allow the virus to come out of the host cell and infect new host cells. Isn't that cool, guys? I bet you did not know how Tamiflu worked. I actually didn't at all. My mom was asking me, like, do you know how it works? And I kind of guessed that it blocked some kind of enzyme or blocked any stage of the life cycle, because this is very similar when we're talking about antibiotics as well. And this is also really similar when we're thinking about gene therapy. So I don't know if a lot of people have even thought that far, but if we want to inhibit a certain gene or we want to activate a certain gene, we can use this kind of process to do similar things. We see this for vaccines, we see this for even cancer. So I don't know if you want me to talk about cancer, but I did a lot of cancer research and was involved in a lot of different clinical trials in which they really did personalized therapy. So they were making genetic therapies to block the different pathways of the cancer. Which is really, really interesting to me. I don't know if you guys can tell, but I'm super passionate about this topic because I love understanding the why to things, and I cannot stress this enough, but you need to understand the why to fully talk and understand what is going on. So I can't stress that enough. That is it for my little rant or lecture on telling you what you need to do and how you need to find your information. But honestly, you need to understand what makes an antiviral drug and why it's impossible for them to actually just come up with one out of thin air. So why can't they just come up with one out of thin air? There's many different difficulties when you're finding an antiviral drug. So first of all, the big one is cost. We need all the manpower and all the researchers in research and development to research how we're going to stop this specific strain of COVID-19. We need researchers on the clock researching the genomic sequence. And yes, they have come up with a genomic sequence, but it's long. We need to see what on that genomic sequence we can target, and we need to understand the life cycle of the virus. That actually is under research right now because I've been looking on the news and I've been looking in my research, and I cannot find the lifespan of the virus, how exactly the virus works. We need to understand the mechanism of everything before we just come up with a cure. Another big point that I want to make is that we need to understand that viruses attack our host cells and use our host cell machinery. So you can see how it's really hard to find some antiviral medication that doesn't give us our symptoms ourselves, that does not hurt our own cells. So that's a big difficulty when we're trying to find drugs, is what are their adverse effects going to be. And actually that's the reason that we have clinical trials. Leave a comment down below if you want me to talk about clinical trials, because that's a whole different topic. But there are drugs that have been in the process of development for almost actually the minimum of 10 years. It takes the minimum of 10 years to come up with a very specific drug. I know that for antivirals, they can come up with more quickly. So you were looking at probably 3 to 5 years, but there's a lot of FDA regulations, and you have to go through research and development, 4 phases of clinical trials. Then you have to go through commercialization, and not only through that, but you have to get all this approved by the government agencies. And you can see how much time, how much cost, and how much effort is going to go into that. Another big point, which I kind of touched on before, was acquired resistance. So I'm sure you've heard that there's acquired resistance or multi-drug resistance when it comes to antibiotics, but the more antibiotics you take, the more resistant the actual bacteria become to the drug. And that's the very exact same logic for viruses. So viruses are smart, just like bacteria, and they can mutate and change their sequence to find a better way to replicate with a host cell. And that's another big difficulty, is like we're seeing with the flu, multiple strains are being mutated and seen throughout, even yearly. So we need to think about that whenever we're just thinking, oh, they can just come up with a cure right away with a snap of a finger. So one more point that I would like to make is preventative medicine. So there's this big debate on vaccines, right? There's anti-vaxxers, there's people who spend their whole career, all these big celebrities, Kat Von D is going to be like, oh, I'm not gonna vaccinate my children because vaccines cause autism. Vaccines don't even work. No, that is not correct. I want to set it for the record here that vaccines help so much to prevent viral diseases, so you do not get them. It gives your host an idea of what they're working with. So when they recognize that virus, they already have the necessary machinery to tell that virus to go away. You do not get sick from a vaccine. That's another misconception. I can make a whole video on debunking vaccines, so let me know down below if you want to see that. Thank you so much for watching my second rant on this coronavirus. How come antiviral medications can't just come out of thin air, and the government has already found a cure, but they're keeping it from us? God forbid. I promise that is not the case. If you want to debate me down below, go ahead. I'd like to see you try. I will respond to all the comments I can. And please give a like to this video if you liked what you saw and you like what I talked about. Leave a comment down below if you have any ideas for videos you'd like to see or any more knowledge you would like me to drop. But thank you so much for clicking on this video, and I'll see you on my next one. Bye!